Okay, this is how to balance chemical reactions. Here's a reaction, nitrogen gas plus hydrogen gas producing ammonia gas. If we look at both sides of the reaction, if we look at the reactant side, we see nitrogen, and we can see that there are two atoms of nitrogen on the reactant side, but on the product side, there's only one nitrogen. So that's breaking the law of conservation of matter. We're supposed to have the same amount of nitrogens before the reaction as after the reaction. So I lost a nitrogen and I got to figure out how to get it back. Hydrogen, on the reactant side, there are two hydrogens in the reactants, but there's three hydrogens in the product. So it's like I created hydrogen. Now to fix that problem, we do this thing called balancing. Balancing makes both sides of the reaction have the same amount of each atom, and the only thing we can do is add coefficients to each chemical. Remember from math class coefficient, it's a big number in front. It's the number in front of something maybe in a parentheses or whatever, but in chemistry, a coefficient is a number in front of a compound. So I can put a coefficient right here in front of the nitrogen. I could put a coefficient here in front of the hydrogen, or I could put one here in front of the ammonia, but I'm not allowed to put anything in the middle of the molecule, and I'm not allowed to change the little numbers on the bottom. And remember how I said in the past, when you have little numbers on the bottom, like all these twos, they're subscripts. We're never allowed to change subscripts. They have to stay the same all the time. So let's add coefficients and see how that changes the balancing or changes the amount of atoms on each side. So I need more nitrogens on the right side, so I want this 1 to change to a 2. I can do that by putting the coefficient 2 in front of the ammonia. And what that does is this 2 will distribute to everything in the compound by multiplication. So I end up with 2 nitrogens, and then 2 times 3 hydrogens, now there are 6 hydrogens. So I fixed the nitrogens, but now I need to fix the hydrogens. On the left side, my coefficient here would be 3, because if I take 3 times 2 hydrogens, I get 6 hydrogens, and now it's balanced. Here's a harder example. This is a double replacement reaction, potassium phosphate plus calcium hydroxide making calcium phosphate and potassium hydroxide. It's a little bit gnarly. Look at all that stuff. So let's count everything out. First of all, potassium. There are 3 potassiums on the left side in the reactants. In the products, there's only 1. Then phosphorus next. In the reactants, there are 1 phosphorus. And on the right side, in the products, look at this. I have a parentheses. That 2 distributes to everything inside the parentheses. So I really have 2 phosphorus in the products due to the fact that there's a 2 on the outside of that parentheses. And if it gets more complicated, when I look at oxygen, I see there are 4 oxygens right there, but there's also these oxygens here. First, I have to distribute the 2 into the parentheses. There are 2 oxygens from the hydroxide plus 4 oxygens from the phosphate. That gives me a total of 6 oxygens on the left side. Once again, there are 2 oxygens over here on the right on the calcium hydroxide plus 4 oxygens on the phosphate. Then in the products, I've got 2 times 4. So first of all, I have 8 oxygens on the calcium phosphate over here, plus 1 more oxygen in the potassium hydroxide. So that's 9 oxygens. Let me erase my work here. 9 oxygens on the product side. Okay, and there's still more. There's calcium. Calcium on the left side, there's only 1 because the calcium is not inside the parentheses. On the right side, there are 3 calciums. Then hydrogen. Left side, there's only 2 hydrogens. That 2 distributes into the parentheses. And finally, on the right side, there's only 1 hydrogen. So everything is messed up, and you have to just pick something and go with it. So let's just pick the potassium since it's first. And let's use a 3 in front of the potassium hydroxide. Now I'm going to switch colors. I'm going to switch to, I guess, green. So I've got 3 potassiums now, but I've got to distribute the 3 to everything in the compound. So now I've got 3 oxygens here, plus the 8 oxygens over here, because 4 times 2 is 8. That gives me 11 oxygens. And for hydrogen, 3 distributes over to the right to get 3 hydrogens. So that didn't really fix anything but the potassium. Let's fix phosphorus next. Hold on.
Due to Power School being down today, Sterling Scholar applications will be due on Monday at noon. So no need to worry about it. Just make sure they're turned in Monday at noon. That's for Sterling scholarships, okay?
Okay. Okay, left side, phosphorus, we need 2 of those, so I gotta put a 2. And notice how the 2 is a coefficient. It is in front of the compound. It's not allowed to go in between any of the atoms within a compound, and I'm not allowed to add subscripts. So now that 2 has to be distributed to the potassium, to the phosphorus, and to the oxygen. So first, let's fix the potassium. Now there are 2 times 3, 6 potassiums. 2 times 1, 2 phosphorus. And now the oxygen. So first of all, 2 times 4 is 8 oxygens here, but don't forget there's some on the right as well. There are 2 oxygens over here due to the fact that there's parentheses. And when I add those together, 2 plus 8 is 10. 10 oxygens. It seems like we're getting nowhere, but honestly, there's really no way around this. You just have to do trial and error, and eventually it'll work. So just relax and enjoy the work here. It's just going to take some time. So we've solved nothing yet. Well, maybe phosphorus is balanced, but let's just move forward and try doing the calcium here. Calcium, I need 3 calcium on the left, so let's distribute that 3 to the calcium hydroxide. That gives me 3 calciums. Now, remember, there's 2 oxygens first, because I distribute the parentheses first, just like math, parentheses first, times 3, because the 3 applies to everything in the compound. 2 times 3 is 6. So I have 6 oxygens just from the calcium hydroxide, plus the 8 oxygens here. Remember that 2 is distributing over there. So I have 6 plus 8. I have 14. Oops, I messed up my calcium. I have 14 oxygens on the reactant side. That's a lot of oxygens. And then the hydrogen, finally, I have 2 hydrogens times 3. I have 6 hydrogens. We're getting close. We're almost there. Let's go back to the top and fix the potassiums. So that 3 that I originally had, that's not going to work. I'm going to have to erase it. And it's going to have to be at least 6. So that way I have 6 potassiums. Let's do the oxygen now. 6 oxygens over here, plus 8 oxygens over here. Oh wait, look, I have 14 oxygens. All right. The hydrogens, I have 6 hydrogens over here. And it's balanced now. That just took a lot of time and a lot of work, but that's what it takes, just trial and error. So if you do this wrong, you might have accidentally gotten something like, I'm going to write an orange or red over here. You might have gotten like a 4 and a 6 and a 2 and a 12. If that happens, when you're done, check your work and see if your coefficients are able to reduce. So if you got 4 to 6, making 2 to 12, from looking at your coefficients, those can all be reduced by a factor of 2, which would reduce down to 2 to 3, making 1 to 6, which is the correct answer. So as long as you're doing your distributions and counting correctly, you're still going to get the correct coefficients. Even if you go over and above what you need, they should reduce down to the lowest possible ratio.